Students. So in this presentation is specifically about 4.3 of your unit 4, and which is classification of hydrocarbon traps, structural stratigraphic and combination. So the content of this presentation is, for the first we'll discuss about what the petroleum system, what actually is a hydrocarbon trap, and how oil and gas accumulates and what are the types of accumulations of oil and gas, and then a brief idea of faults and faults as they also form hydrocarbon traps, which we'll discuss. So before discussing the traps, let's discuss about the petroleum system. So what constitutes a petroleum system? So in a petroleum system, we have some rocks which are permeable that allow oil and gas to freely pass through them. And we have some set of rocks which are impermeable and they block, since they are impermeable, they won't let any fluid to pass through them. So naturally they'll block the passage of oil and gas through them. So as the oil and gas it migrates, so uh, uh, it rises up, so it's capped by an impermeable rock, and this way it forms an oil trap. So this specific figure, it's an example of a dome trap, which is otherwise called as anticline trap. We can see there are a specific set of folds here, and we have oil present in the at the apex of an anticline. So at the bottom, we can see there are permeable rocks which have eventually, allowed the migration of oil. So they have passed through them. But here in this kind of a rock, which is white, lighter in shade, it's impermeable rock. Hence, it has not allowed this oil to pass through it. So the oil, it is stored, or it is accumulated at this specific set of point, or at this point of a dome or anticline. So let's discuss how actually a trap form in nature. So we can see here in this figure, we have a formation of a basin. So the sediments is deposited in this, and then eventually sediments is being deposited, and the thickness of that sediment layer, it's increasing. So the sediments, sometimes what happens is in the sediments we have organic content as well, so organic matter. So if we'll have the organic matter present in that sediment, so eventually that sediment will form a rock which will be called as a source rock. So this will be the rock which will be forming oil and gas in future. So in earth crusts, there are specific sets of movements that are happening. So these movements, there are external stresses happening going around. So they cause folding and breakage of these sedimentary rocks, and hence we get an accumulation zones. So these zones, they are called as traps. I mean, we get a full structure of a reservoir or a trap which will in which the oil and gas accumulates. So here you can see the specific sets of traps which we have. So in an petroleum system, a trap or in a hydrocarbon or in a trap, we must have a presence of an impermeable rock, a seal rock or a cap rock, which we discussed in our previous topics. And usually we must have that in a convex shape, so that it forms a dome. It allows a space for oil and gas to accumulate. And apart from that, we'll have a reservoir rock as well, which will have a property of being porous and permeable, so that it can store oil and gas in it. So when we have a big, substantial amount of oil accumulation, we'll call that reservoir as a oil field. So in this slide, we'll discuss about the types of oil and gas accumulations. That means the types of hydrocarbon traps. So principally, the major we have two: structural traps and stratigraphic traps. So in this figure, we have all the kind of traps mentioned here. Structural trap, you can see it's because of a fold, or we have again intrusion of a salt as well, because the salt is lighter in density, so it pushes up. We have a fault as well in this figure, and we have a stratigraphic, pinching out as well. So in stratigraphic traps, the stratigraphic trap occur when the reservoir rock, it thins out, it pinches out, so it will form a stratigraphic trap. Why? Because this layer, this is usually impermeable, okay, but in there we have small lenses of source rocks as well as reservoir rocks. So the oil, it's there is a barrier. The oil cannot migrate anywhere else. So this actually it is now an hydrocarbon accumulation, or it's a kind of a trap. So this is an example of specific stratigraphic trap. So if you'll see here, in this scenario, we have a structural trap, which is often found along the edges of salt domes. Here, again, we have, because salt is again impermeable, and then this layer is again impermeable, so it's not allowing oil and gas to move through it. So we'll have a trap here as well. And then you can see again it's a fault here, and again we'll have oil and gas accumulation here along the fault zones because of the presence of impermeable layer here. And you can see these is oil rigs. They're specifically targeting this trap. This is the significance of a trap, because in a trap we are bound to find oil and gas. So what we do is we target these traps only. These are the places which we want to drill so that we can extract oil and gas. So here this is a figure uh, from Cardigan in West Wales in UK. You can see anticlinal folds. They are exposed here, just to give you an idea how these folds happen. They are in nature. So this is a real-time picture for you to see. So let's talk about, I mean, when we say the structural kind of traps. So for that, you need to have an idea what different types of folds and faults we have in our environment, in our on our Earth. So you can see we have symmetrical type of folds, anticline and a syncline. And then we have asymmetrical type of fold, we have recumbent fold, we have overthrust fold. So these are the settings which are possibly, we will encounter in nature, and they'll possibly be, um, they'll form a hydrocarbon trap. Similarly, in case of faults, you can see we have normal set of faults, and how these vary normal faults A, B, C, and we can have, you know, a wide array of combinations or pattern of fault formation. Similarly, we have reverse fault as well. You can see the scenarios, different scenarios in which we can encounter faults in nature. So this is again an example of Ordovician black shales in West Wales, again in UK. You can see the anticline structure in it, how big it is. So this is my thank you slide as well, because this is not a big topic. It's pretty much simple. You have just two kind of it traps, but I want you to focus on this figure, because it shows all kind of basic four types of traps which we have in nature. The first one is dome or anticlinal trap. You can see normally we have three lithologies: A, B, and C. A is your impermeable, B B is your reservoir rock, and C maybe it's a source rock. So uh, we have natural gas and rock oil which is present at the dome in the space, because the A lithology, it's not allowing it to pass. Similarly, if we look at the example of fault trap, there is a fault, okay, and fault, it has again stopped the migration of oil, and we have impermeable layer again A, which is encountering uh, the upward movement of natural gas or rock oil. And again we have salt dome as a kind of a trap. It's again a structural kind of trap, and we have natural gases here at the margins of the salt dome. uh, so we might have cap rock as well, so it has all the elements of a petroleum system as well. And similarly we have a stratigraphic trap, again A, B, and C. You can see there is a pinching out of layer B. So it's a source rock, and it's capped by A. So that's why it forms a barrier, and it's not allowing oil and gas to move somewhere. So we have a D, which is a drill in all the four figures. We are drilling from this spot oil to the top. So the combination trap is sometimes we might have all the three settings in just one area. So as the name suggests, it's the combination of stratigraphic as well as structural kind of trap. Okay, thank you.